Hey, what's going on, guys? I'm doing 2.3 example 9. All right. Designing a box. Dixie Packaging Company has contracted to make boxes with a volume of approximately 484 cubic inches. Squares are to be cut from the corners of a 20-inch by 25-inch piece of cardboard, and the flaps folded up to make an open box. What size square should be cut from the cardboard? All right, let's get our cardboard box. I will go ahead and get this rectangle tool. Now we have a piece of cardboard. Let's go ahead and crease it. So get those corner boxes, right, like that. This way, it's not perfect, but you guys get the idea. And finally, like that. So those corner squares are going to be cut out, and then we're going to be folding up on the creases. And as you can see, these are the corner squares that we are going to cut out. And let's get the dimensions. Let's see. So I'll use this. So the size of the cardboard this way and that way. It looks like it said that it was what, 25 by 20. All right. And what's next? Oh yeah, we need to find the sides of the square, right? What's the length of each side for the square or squares? And that's an unknown. So those are all x's. And so how do we solve for that? Well, they gave us that volume is 484 cubic inches. So it's a volume of a box or rectangular prism. So we need to know the formula, and I'll write that right here. Volume is equal to length times width times height. So we need to get this formula, but represented by our current situation. So we know that the volume, we want it to be 484 cubic inches. So we can write 484 cubic inches right over here. Right, so we're replacing volume with 484. Now we need the length. And so let's see if I can do this color-coded. Not sure if I can, but I'll try my best. So length would be from here to here, right? And so length would be, that looks like that whole entire side's 25, but then you'd be cutting out those squares. So you'd be cutting out a length of 2x's. So it'd be 25 minus 2x. All right, let's see. The width, same idea. Do I have any other colors? I can use this red one. Or actually, can I change the color? Yeah, I can change the color. So let's do green. No, I already did green. Let's do this purple color. I feel like purple. There you go. So go this way, right? In that case, that width is going to be 20 minus 2x. So purple again, 20 minus 2x. And then finally, your height is going to be the x. All right, so there's your 25 minus 2x times 20 minus 2x times x. That's going to be a cubic function, all right? And it's going to be an odd function or odd polynomial. But at this point, we can actually stop with our handwritten work because conceptually, we have the length and the width and the height written as a function of x. And we know it needs to equal 484. So at this point, we don't even need to multiply it. We can just go to Desmos and put in our function, our volume function right over here. All right, so I will put v of x for volume. I believe it was 25 minus 2x, 20 minus 2x, and x. All right, so there's my volume function. And notice it's not very pretty the way it looks right now. It's just like, it looks like a red straight line. If I zoom out, it is very, very vertical. So what we want to do is, if you're using Desmos, don't forget you can hit the shift button, and then you can alter the window just by dragging it. And then I can do that same thing with the y-axis, and that's a much nicer graph. Okay, probably can do something like that. All right. That's a pretty good looking graph for us to analyze now. Now remember, we want to know what x value is going to get us a volume of 484. So just understand that this this graph, in fact, just to give you a little Desmos tour, you can add a label. The x here is length of side of square, right? So that's what the x represents, and this one is the y-axis would represent volume of box, right? So that way we don't lose track of what's going on. So notice, depending on the size, I can even click up here and get a max value. So it looks like the maximum volume for this box is 820 cubic inches approximately, if you cut it about 3.6 or 3.7 inches for the side of the square, but that's not what the question's asking. The question specifically is asking, when will it equal, what cut will get you 484 cubic inches? And you can just go ahead and put y is equal to 484. There you go. And now we can see that if I click here, click here, click here, we have 3 separate x values to get you a volume of 484. 1.2 inches approximately, 6.9 inches approximately, and 14.4 inches approximately. Now it's cubic, so that's to be expected that we possibly can have 3 solutions, right? But there's an issue with these. Should I write all 3 solutions? So I'm going to write them for now, and then let's take a look and really establish whether we can keep all 3. So 1.2, 6.9, so let's do that. We have x is approximately 1.2 inches, 6.9 inches, and the last one is 14.4 inches. All right, so remember, contextually speaking, this box is coming from a piece of cardboard that's 25 by 20 inches. Well, if x was 1.2 inches here, whoops, let me fix that. If this was 1.2 inches here and this was 1.2 inches here, and we cut those out, well, 25 inches is a lot to take away and cut out 1.2, 1.2. So we're good there. Same thing here, 1.2, 1.2, right? That's possible. But what happens if I try to do, let's say, 6.9? So that's about 7 inches. So if I cut out 7 inches here and cut out 7 inches there, well, that's 14 total, giving me still 6 inches approximately in the middle. So that makes sense, and that works fine. However, if you try to cut out 14 inches here and 14 inches here, you don't have enough cardboard to do that. So we have to not take the mathematical solution of 14.4 inches, and really our actual practical solutions is 1.2 and 6.9. And so those are your 2 answers out of the 3 mathematical answers. And the last thing I will show you guys is the idea of, again, if this is a cubic function, notice if I zoom out, it has the end behavior of a cubic, right? It's odd, and therefore it's going to be negative infinity going to negative infinity and positive infinity going to x's positive infinity. But another thing I want to show you really, really quickly, and then that's it, is that another way you can solve for this is assuming that, hey, you know what? If I take this and I subtract 484, because usually when you do these by hand, you have to set it equal to 0, right? Usually when you do synthetic division or quadratic formula, you need that to equal 0. So just relating to the graphical part, if I do minus 484, I've done a vertical shift down. But as you can see, when you set it equal to, if you subtract 484, you'll have a 0 on that side. And now if you take a look, notice there, and there. Notice these are the same exact solutions. And this equation really is the same equation, right? You've just moved the minus 44 to the right, or the 44 to the right side of the equation. And again, in terms of graphical, it is a shift down, and now you're looking at when it crosses the x-axis. All right, thanks guys. Hope that made sense. If you have any questions, comment or email me.